All right, guys, we're going to do a quick video here about synthetic division versus long division. And we're going to specifically focus on the same example that we used for the long division example from last time, which was a cubic polynomial. So there's only these three roots here. And what we want to see about these three roots is that we can divide out any of the three here. So when we do synthetic division, you're going to want to make sure that the equation is in this standard form. Okay, we can't really do synthetic division in these other formats. Now, the advantage to having these other formats is that if you see it in factored form like this, it's very easy to divide something out. So what you would want to notice is that if you were looking at this equation here in factored form and you needed to divide out a specific factor, it's really easy to do. All you would do is write out the equation like this in this factored form. And if you were going to go to divide it by a certain factor, it just cancels out. That cancels out with that when they match. So when we have a polynomial in factored form, it's actually usually a little bit more of an advantage to just leave it in factored form. I know a lot of us will probably have that little bit of anxiety of like, oh, we'll see what we can do. We can multiply these things together. We know to FOIL, we know to distribute. That's good. But if you see something like this, usually better just to leave it in that factored form. There's no use making life harder, multiplying all of these things in the top together just to divide something out with this process when they can just cancel already. So make sure that if you see problems like that, or for example, if you see a problem like this, where everything is factored up here, but maybe you've got this quadratic equation down here in the bottom. If you're going to divide by a big quadratic like this, usually better to go in and factor this the way that you know how to. Whatever your teacher has taught you how to do, whether that's using a box to factor or slip and slide or whatever nonsense you learned of factoring quadratics. If you factored that quadratic like this and said, okay, hey, we've still got the same factors in the numerator, x plus 1 times x minus 3 times x minus 2, divided by, now in the denominator, this ends up factoring into x minus 3 times x plus 1. And what you would want to notice there is that you don't need to do long division with this, especially when you already know the factored form of what you're dividing into. You just cancel out things that match. Those two match. These two match. So your answer when you're done would just be this x minus 2 factor. All right, but that's beside the point. We want to talk about synthetic division. And what you need to know about synthetic division is that you're going to basically take your standard form. So it needs to be in standard form like this. If it's not, try to take advantage of one of those two methods that I just talked about. And what you're going to want to do is copy down the coefficients of the standard form the way that you see them. So if it's not in standard form, make sure that you rearrange the polynomial so that it is in that descending order from biggest exponent down to the constant term. And so I copy these things down like this. And what I'm going to do is, depending on what I want to divide out, so let's focus in on this middle graph here, this middle equation here, which shows us one particular factor. It shows us that x minus 2 is a factor of this equation. So let's try to divide out x minus 2. And the way that we do that with synthetic division is we take the value from this graph that corresponds with that root, that position on the x-axis, and we use that value of positive 2 to divide that out from these coefficients. So when we're looking here and we're dividing by this factor, we know that we need to look at the graph and understand that root is what we're going to use to divide this out. So we're going to take that value of positive 2 that root. And usually we're going to do it like this. I've seen some people have this set up. Both of these are exactly the same, no matter which format you choose. It's really just an organizational tool is all. So either way, it doesn't really matter. I usually use this way just because it looks a little bit cleaner at first. And the way you're always going to start is just drawing this bar underneath here so that you get this first term will 100% of the time always drop straight down. And you're going to go through a series of multiplications and additions. And what you're going to do here is drop this down first. Now multiply by the root value 2 times this number. 2 times 1 is 2. You move that up diagonally, and then you're going to add straight down. So once I do multiplication, then it comes time for addition, right? And I just kind of rinse and repeat here. I just continuously cycle through these two operations. So I'm adding straight down. -4 plus 2 is -2. Now that I've done addition, it's time for multiplication again. Again, the root times the value down here. 2 times -2 is -4. Now it's time for addition again. So I'm going to add straight down. 1 plus -4 is -3. Done that twice. And now I'm going to cycle back through, do multiplication one more time. The root 2 times -3 is -6. Add straight down. That's 0. So focusing in specifically on this 0, when that last value from the last column here gives you 0 as a response, that always means that 2 was a root, which remember means that that's the spot that it crosses on the x-axis. It crosses at x equals 2, and that means that the factor then was x minus 2. So when we look at synthetic division, you got to think a little bit more about what you're seeing or what you're doing than you do with the long division. But a lot of people will prefer synthetic because of its simplicity. You're just dealing with numbers and constant values. The additions and multiplications are usually all within the realm of our times tables from elementary school. So it keeps things simplified, but you do have to actually interpret the root to the factor, right? You've got to do that little bit of transition piece. Whereas when we do long division, we see 0 as the remainder. We know that we are basically dealing with exactly what we see because we would have been dividing by this x minus 2 factor. Now, the last part here about synthetic division that you need to make sure you get is that when you have this response here, these 3 positions are the only 3 positions that are a part of your answer. The 0 as a remainder is not a part of the answer anymore. Now, what we do with these 3 numbers is we take these 3 numbers, and notice those are going to correspond with this up here, right? This version up here. You write them on the exponents, on the variables in descending order. So you take away, right? The green equation corresponds with the green equation up here, right? This green equation corresponds with this. And the blue equation is our response to having canceled out this x minus 2 factor, right? So what we're looking at down here is that we need to go in and we need to include these variables and exponents. So we would know that if it was a cubic and we divided out a linear factor that has an exponent of 1, that this exponent goes down by 1. So if it was a cubic originally, 3 minus 1 is 2. This next term, again, goes in descending order. So you put the x term there, and this would be a constant, right? X to the 0 power. So all of these things go into synthetic division, where we can see that it works very, very similarly to long division as far as what it gives us and what it does, but the process can be a little bit easier. All right, so hopefully that was a good explanation here. Make sure that you guys check out the other video for long division to make sure that you understand how to do both of these versions.